Welcome to qnawire.
Okay. This is basically a propagation of error or propagation of uncertainty question. So first, we have 100 mils. We're going to ignore the uncertainties for now. The concentrated HCl solution. This is 3.00 molar, and we're diluting it to 500. Dilute to 500 milliliters. Okay. So first of all, we need the concentration, right? And to get concentration, if we know the get final concentration from a dilution, we know the initial volume and the initial concentration. We multiply those together and divide by the new concentration. Okay. Something else we could do that's kind of a faster trick is if we know the initial volume, we divide it by the final volume, and whatever that factor, unitless factor, turns out to be, we multiply it by the concentration there. So that would look like 100.0 milliliters divided by 500 milliliters equals 1/5. So the final solution is 1/5 times 3.00 molar, or 0.60 molar. Okay, so that is our final solution concentration. But what about the uncertainties? Okay, so if every time we do a mathematical operation, we have to propagate the uncertainty in the initial measurement, right? And the rules for that, note that this is all multiplication, right? We're basically doing, or division, which is like multiplication, right? We're doing 100.0 milliliters times 1 over 500 milliliters times 3.00 molar, right? This is multiplication, this is multiplication. We have to, there's a rule basically for how we would compute the uncertainty in any of those answers propagating to our final solution. And the rule goes like this. The uncertainty in our final answer, which I'll call A, sub A, so this is going to equal A, is going to be equal to A itself times, and then it's the square root of, and then for each of these terms, you take the uncertainty in that measurement. So I'll just say like general uncertainty, which is this little delta, divided by the value itself. Okay, and then you take that and you square it, and then you add all of them together. So we'll go through and do that here. So for example, the uncertainty in our 100 mil measurement was 0.2 mils. So we do 0.2 milliliters over 100.0 milliliters squared. Okay, and then for 500 milliliters, right, we do the uncertainty in our 500 milliliters, which is 0.4. We divide it by 500, and we take the whole thing, we square it. Okay, and then in our 3 molar, I guess it's a 2% uncertainty. I can only assume it's meant to be a 2% uncertainty or a 0.2% uncertainty. They don't really say. So 1% would be 0.3. So it should be 0.006 over 3, all squared. That would okay, because what I'm seeing is at 3.00 molar, 0.2%. But they don't list an uncertainty. All the other ones in parentheses list an uncertainty. So assuming this 0.2% is supposed to be the uncertainty, it's either that or we're just supposed to ignore that and not have a value there. But if it is true that the uncertainty is 0.2%, then it should be 0.0006, and that's molar over molar. Okay. Now we should be able to calculate the uncertainty for each of these. Okay, or the each of these fractions squared. Okay, so first up, we have 0.2 over 100 all squared. I get 0.00004. Okay, then we have 0.4 over 500. Get 6.4 times 10 to the negative 7. In fact, I can probably just say 1, 2, 3, 4, 5. Rewrite this. That's 4 times 10 to the negative 5. Okay, and finally, we should get 0.00006 divided by 3. All squared. And we get 4 times 10 to the negative 6. Okay. So then we add all these together, take the square root, and multiply it by A. A is, in fact, what the answer was. So A equals, this is A. Okay, so what is the square root of 4e minus 5 plus 6.4e minus 7 plus 4e minus 6? 0.6 molar. 0.00668. And so I get as my answer 0.004009. Okay, so the final answer with the uncertainty should be 0.60 molar plus or minus 0.004 molar.